Hey there, folks. It is Wednesday, the 4th of November, and this is chapter 18, I believe. So we're getting near the end. We're going to be looking at oceans today. Um, so let's jump right into it. We're looking at oceans and coasts. Now, again, this is one I think I explained that we don't live near an ocean, so we'll go through this a little bit quickly. Plus, a lot of this stuff we've talked about already. We were talking about plate tectonics, and we'll talk about some more of this stuff when we talk about weather and climate, and definitely when we get into climate change. So we're just going to hit some of the highlights with Chapter 18 for the most part. But it is interesting to think about the fact that we know, or still know, very little about the ocean. And up until just a few decades ago, knew almost nothing about the ocean. When we sent men to the moon, we had very good maps of the moon, and I remember the comment that we know more about the surface of the moon than we do about the surface of the ocean. So it has been quite a mystery, and we're learning more and more about it, and we're learning about how it affects climate and things like that as well. But like I said, we'll get into that in a little bit more detail later. But this is just some of the exploration that has happened with the ocean. So we know some of the landscape beneath the sea, and again, we touched on a lot of this when we were talking about plate tectonics. At one time, we thought the ocean was just a big whole bunch of nothing under there, but now we know there's tectonic activity. There are plate boundaries there, plates that are moving apart. There's volcanoes under the ocean. So there's all kinds of, and trenches. So there's all kinds of features that we didn't know about before, but now we know quite a bit about now. And here are some of the things that we look at. The continental shelf, which is actually part of it, has continental continental plate material that goes into the ocean. So even though you're at the beach, the continent still goes out sometimes for a few hundred miles before it actually becomes ocean plate. The abyssal plain, which is we thought was nothing there, but now we know there's quite a bit of life there, mostly scavengers that scavenge the food that's living closer to the surface where there's sunlight. And so there's a lot more we're learning about the bottom of the ocean, the surface of the bottom of the ocean. So again, we've talked about most of this. Here we see the Mid-Atlantic Ridge. We see these trenches formed by plates in subduction. We see islands formed, mostly volcanic. And then there's that the abyssal plain, this sort of pretty much flat emptiness, which is just ocean plate, right? That dense ocean plate. And here's a picture of it. You can see just mud, and there's a few organisms again, and these are just scavengers that are cleaning up whatever sinks to the bottom that they can eat. Here we see the Pacific Ocean, and there again we see trenches formed by subduction. We see some seamounts, some of them volcanic, some of them pushed up by, again, plate tectonic activity, and then the plateaus. So in the ocean, we have currents. So anyone who's gone swimming in the ocean knows that there are currents. Some of them can be fairly dangerous. We'll talk about those in a little bit. But essentially, currents are caused the same way wind is caused in the air. When we talk about water and air are basically the same things. We think of them as moving in the same way. So we'll get into that more when we talk about weather. But in fact, currents are caused simply by changes in temperature and in amounts of water. So you can get currents caused by tides. We'll talk about that a little bit more detail. And by the salinity of the water. So if water has more salt in it, then the water is more dense and it tends to sink. If water is fresh or has less salt in it, it tends to be more buoyant. So as you go deeper, the water gets a little saltier. and that causes some currents as well. And we'll talk about that in a little bit more detail. Here's some folks actually getting salt. So you may use sea salt when you go cooking, and it's real salt from the ocean. These currents are literally rivers in the sea, and here we'll see a whole map of some of these currents. These are major currents. There's all kinds of minor currents that go all over the place, and once you get near the coast, there's currents that are even minor than the minor ones. But here you can see some of the major ones. Here's the Atlantic Ocean. And these answer some questions about, like when early explorers came, Christopher Columbus leaves Spain, or Portugal rather, and he's going to end up down here, obviously, because he's following a current, right? If you want to go up to the north, you've got to kind of go through this area and back up. These areas in the middle are areas where there's not much wind and not much current. So this was kind of a danger zone for early sailors. You didn't want to get caught in the Sargasso Sea because if you did, you might sit there for weeks sometimes without any air to move your ship. So these are we're going to look at some kind of the major current here in a little bit. But this is basically a map of how currents work. And then again, the temperatures you can see, colder temperatures and warmer temperatures are going to be the drivers for these currents. So here are the warmer temperatures, and here are the cooler ones. Now, excuse me, we're going to get into climate again and weather, but I want you just to look at one interesting little thing here. If you've ever been to Europe, the climates are much milder in Europe, but look how much farther north they are. Here's Maine. This is our Maine. This is where it snows and is terribly miserable, but look how much farther north Europe is from the standpoint of latitude. But it is milder because of these warmer currents. So as you can see, this warm air and warm sea comes up from the south and goes to Europe and keeps Europe cool. You can imagine what would happen, and it has happened, that if this warm current had gotten shut off, Europe would be basically back almost in an ice age, wouldn't it? So these warm currents not only run the ocean, but they also are going to drive climate. We'll see that again in some chapters coming up. All right. So some of these currents as well are caused by the Coriolis effect. Now, the Coriolis effect is the fact that the Earth is spinning. And again, we'll get into this a lot more when we talk about weather, but I want to introduce it here. And you may have heard of this before. But the Coriolis effect is essentially because the Earth is spinning, then if you're down here on the equator, you're actually traveling faster than people up here. So we live up in North America. We're actually traveling slower around the Earth, right? It takes the same amount of time, but we're traveling a shorter distance, aren't we? And so these folks are traveling a longer distance, so they have to go faster. And so there's this fact that even though the Earth is one ball, speeds are actually faster here. So as weather or as currents move, they get pushed in this direction because they're traveling quickly, and then all of a sudden they slow down and get pushed in this direction. And we see this in our weather, and again, we'll get into that with weather, but here you can see it even in the currents created by the Coriolis effect, simply because of the way the Earth is spinning. So this is the great gyre, the great conveyor belt, as you were, that circulates water all through the oceans. And again, you've got to remember the continents are constantly moving, so this has not been here for very long. This gyre, this conveyor belt, which, as you can see, warm water moves through the Indian Ocean up into the Atlantic Ocean, and then as it gets to the north, it cools, and we know that cooler water, cooler air is more dense, so it sinks to the bottom, doesn't it? And then it moves south, right, into the Pacific, and then again gets warmed up. And so this great big belt, this great big conveyor belt, literally, is what has been driving a lot of the climate for, as it says here, for quite some time. Now, one thing we do want to talk about are tides. And as you know, if you've ever been to the beach, gone swimming to the beach, you know that you come to the beach and you look out and you see a nice big wide beach, and then you come back a few hours later and suddenly the beach is gone because the tide has come up. So tides are basically the water changing position, getting higher, the water level getting higher because of gravity. So the sun and the moon are pulling on the earth, and as it does, it's the ground doesn't move very much, but water, which is much more fluid than rocks, does move quite a bit. So we have tides, at least a couple of them every day. If you live near the ocean, you know this quite implicitly. Sometimes the tides are very small, but like in this bay here, the tides can be very large. So here the tides can go up as much as 40, 50 feet, and boats have to take that into consideration. But here you can see how tides work. And again, this should be review, right? You should have had this in third grade, and I know you had it again in middle school. So this hopefully is review for you. But the moon is going to pull uh, the water out, right, as it spins around the earth once a month. And then the sun is also going to affect it. So here, when we have the moon and the sun pulling at the same time, that's when we get extra high tides, right? Or if we have the sun and the moon sort of opposite, the moon's pulling this way and the sun's pulling this way, we have very low tides. And so people, again, who live near the ocean, they're well aware of this. Here you can see tide in Cornwall, England. Here's the guy standing on the rock fishing, and here's the same rock with the water gone. So anyway, tides are important to understand. Plus, they generate a lot of these little currents, right? So again, if you're swimming and the tide is going out, it can be pretty dangerous and pretty scary because the tide is literally pushing you out. I had an experience where we were in North Carolina and we're in a little boat and we're rowing the boat back into shore, but the tide was going out, and so no matter how fast we rowed, we were actually going backwards. It wasn't until we kind of looked over a few yards over and could see some birds not having that problem, we moved over and was able to get out. So tides can cause a lot of these currents that can affect the way the water moves. And here it's kind of explained using a couple of people. If you've ever played a little game with a little kid, right? You kind of spun them in the air. You can, as you're spinning the kid, it looks like the kid's spinning around you, but in fact, the kid is pulling you a little bit too, isn't it? And so your center is not actually you. You're kind of spinning around a center. And that's the way the Earth and the Moon works. The Earth is much more massive. And so when the Moon is spinning around the Earth is being pulled kind of back and forth as well. We don't feel it, obviously, because it happens slowly from our standpoint. But these types of forces cause the water to literally slosh around in the ocean, kind of like water sloshing around in a bucket as you're trying to carry it. So this is a good little thing to read. It gets good understanding of how tides work and kind of why they're important. Then we've all, again, if you've been to the beach, you've experienced ocean waves, and waves, of course, are a product of wind. So if we didn't have any wind at all, we wouldn't have any waves. And sometimes you go out on the sea and that there is no wind, which is rarely, but sometimes there can be, then the ocean is pretty calm. But if we have a storm, if you have a lot of heavy wind, you're going to have heavy seas as well. There are a lot of very rough waves, and so waves are caused again by the wind. And the wave works just like it does any kind of wave, like a radio wave or a microwave, anything like that. You have wavelengths, the distance between the crests of waves. You have amplitude, you have modulation, and you have wave movement. So these waves are mechanical waves, so they have to have a medium, and the medium, of course, is water. It's like sound waves. Sound waves are a mechanical wave, and they need a medium, and their medium is air. So if you were in outer space with no air, you couldn't talk because there's no medium. So these waves work with water, and water is the medium. And as you can imagine, these waves can be very effective in terms of erosion, right? So taking big rocks and breaking them up into little rocks is one of the reasons we have a beach, right? All that sand used to be big rocks, but the waves over thousands and thousands of years have reduced those big rocks into very small rocks. And so that's why we see beaches. And these beaches, of course, can change. They can move. The sand can move as the waves move and as the current moves. They call that, there's shore drift, right? And you've noticed this when if you're swimming at the beach and you feel that the current's kind of pulling you down from where you laid out your towel. When you go back in, it's in a different position because the waves moved you down. Now, we've heard a lot about rip currents and how dangerous they are. A lot of people drown because of rip currents, and this is exactly what we were in our little rowboat. But you can see what happens here is that as the water begins moving out of a channel during low tide or even high tide would be pushing you back in, but low tide is more dangerous because it's actually pushing you out into the ocean. You can see we have a sandbar here and a sandbar here, and then all the water, just like a big tube, gets channeled through here, and it's moving at a very high rate of speed, very fast. So if you're swimming here, you might be swimming in this nice quiet area and all of a sudden come up into here, and all of a sudden you're being drug out into the ocean. And so that's why they're so dangerous, is because what people then do is panic and try to swim back just like they came. And as you try to swim back, you're swimming against the current and actually wearing yourself out and not making any progress. So that's why they tell you if you're ever in a rip current like this to swim this way. Don't swim towards shore. Swim this way, because you can see what happens if you swim this way. You get out of the current and you can go right back to the beach just like before. And it's good advice if you've ever been in a situation like that. Hopefully you haven't. But anyway, there's more information here about beaches and dunes and all those sorts of things. And again, if we were living near a beach, we might go into this in a little bit more detail. But we're not going to spend a huge amount of time on this. But I do want you to read it because it is interesting. And maybe one of these days you'll get a really great job somewhere near the beach. And so this information would definitely come in handy, right? Here we see the effects of erosion. Again, we've seen this in rivers and that sort of thing, where the rocks that are softer, that are at the bottom, get eroded away. The harder rocks are up here. And then, of course, they have a tendency to collapse. And that's how we see some of the features we see in some of our beaches. And again, I'm not going to go into a huge bit of this, but definitely read it. It's very interesting stuff. Because oceans have been so important in human civilization in terms of exploration and now in terms of trade, those sorts of things. So learning more about the ocean was very important. Here's your big pictures, and again, some of these currents where we have warmer water kind of on top, the colder water sinks, and the currents move in opposite directions. So that's interesting and very important to understand. And it will be when we start talking about climate change and we start talking about weather. And yeah, they've affected, when you go back in time, they've affected all kinds. Here they're talking about this, the glaciers that hit Europe and the United States, excuse me, North America. And of course, how these coastlines change. So when two plates come together, the coastlines could possibly change, couldn't they? And then we see some issues with coasts, not to mention the fact that water sea levels are rising. And a lot of people, I can't quote you the exact number, but a lot of people, more than about half the people at least in the United States, live near an ocean. Still, a lot of our big cities are still near water, and they could be inundated with changes in water elevation. Then, of course, we have hurricanes and floods and that sort of thing, and that we'll talk about in more detail with weather. But this is oceans. All right, let me see if there's anything else. I guess not. So this is going to be a quick one. Here are your review questions. that you can answer. There's plenty of them here to answer on 692 and 693. And I will see you next time.